Here we're going to find the area of the part of the surface z equals 4 minus 2x squared plus y that lies above a triangle that has vertices 0, 0, 1, 0, and 1, 1. From an earlier video, we have a formula that we can use if our surface S is given by z as a function of x and y. I'm not going to do that because I don't want to try to memorize that formula when I have one that uses a cross product. You can memorize the formula if you want. I'm going to show you using the cross product. First, we're going to write down what the parametric equations are. X equals x, y equals y, and z is equal to 4 minus 2x squared plus y. So r is a function of x and y and equals x, y, 4 minus 2x squared plus y. We need r, the partial of r with respect to x of xy, and the partial of r with respect to y of xy. With respect to x, our partial derivative is 1, 0, negative 4x. With respect to y, we get 0, 1, 1. So rx cross ry is equal to the determinant ijk. Second row is 1, 0, negative 4x. The third row is 0, 1, 1. This gives us the vector 4xi minus j plus k. So the magnitude of the partial of r with respect to x cross the partial of r with respect to y is equal to the square root of 16x squared plus 2. Now we need to deal with our region D. The region D has vertices 0, 0, 1, 0, and 1, 1. And so we can see that the line that connects 0, 0 to 1, 1 is the line y equals x. And so y is going to go from 0 to x. X is going to go from 0 to 1. Our surface area integral then becomes the integral from 0 to 1 of the integral from 0 to x of the square root of 16x squared plus 2 dy dx. Now, based on the region D, we could have set this up as dx dy. However, that would cause a problem for our integral. It'd be difficult to integrate the square root of 16x squared plus 2. You could use a trig substitution, but by using this order of integration, we now have that this is the integral from 0 to 1 of y times the square root of 16x squared plus 2 as y goes from 0 to x dx. And so we end up with the integral from 0 to 1 of x times the square root of 16x squared plus 2 dx. With this factor of x outside of the square root, we have basically our du. I just need to multiply and divide by 32. I will leave it to you to verify that our result is 13/12 times the square root of 2.